Okay, so I need to at least say this. There's a theorem that exists that I'm not going to prove, but is true, that says that the inverse Laplace transform is a linear operator. Meaning it acts like integrals and derivatives. So that would mean essentially if I have the inverse Laplace transform of, like, say, a times some capital Y function, where a is a constant, that this would be a times the inverse Laplace transform of this capital Y function. For constants. In other words, feel free to pop constants through this thing. What was the other one?
Addition.
Yeah, that it breaks nicely across addition. So maybe you do, like, the inverse Laplace transform of y1 plus y2 would be the inverse Laplace transform of y1 plus the inverse Laplace transform of y2. You can break across finite sums. Please don't have Laplace transform problems with infinite sums in them. Those things act very strangely. Don't do it. Cool. That's basically a problem about interchanging of limits. Limits are not always interchangeable.
Yeah.
Right? So if you have, for instance, a limit as x goes to a and a limit as y goes to b of some thing of x and y, it's not always true that this is not necessarily equal to the limit as y goes to b, the limit x going to a from x and y. It's cool with that? And then, so here, similarly, the inverse Laplace transform, right, is some kind of a limiting object, right? Like, I believe that it's somehow related to integrals or derivatives because it has to be. Right? And so if I had an infinite sum in here, that thing would have a limit on it. And I would be worried about the possibility of interchanging those two limits. You guys see that? This is kind of why you should worry about swapping these two symbols. Right? Like, this is not necessarily always true. It depends on the class of the object that's in that argument. It's cool that? You guys recognize that this is actually something about this? Right? The derivative and the integral are both defined in terms of limits. Which limits are they? The integral is limits
of integration.
Is it limits of a sum?
Yeah, it's limits as the delta x's goes to 0, right? And then the derivative is the limit as that displacement of a secant line goes to 0, right? So this is a limit h tending to 0. This is a limit delta x tending to 0, or the number of partitions tending to infinity, either way. But interchanging those two things gets, like, fundamentally wobbly, right? Because you're saying, do I cut it up into lots of pieces before I calculate the derivatives or after? And that shouldn't work, right? It just so happens that it's interchangeable most of the time. Cool?